Hello, hello, scientists. It is so good to see you this week. I don't know if you've noticed, but the leaves are changing and they are falling off the trees, and the weather is getting a little cooler than what we were used to in the summertime, which means the season is changing. Did you observe that? My name is Mr. Frills, and I am the principal at KIPP Wonder Academy here in St. Louis. Welcome to Room 9, St. Louis's largest classroom. The material that I planned for us today is mostly for second graders. However, if you are a person that wants to learn some science, come on into the room. Room 9, that is we're here to learn a little bit more about some science. Today, we're going to spend some time on the phenomenon of erosion. And there's a lot of things that we could talk about with erosion, but today we're going to compare the changes on Earth's surface. We'll be collecting some evidence so that we can explain how fast and slow changes occur on Earth's surface. These changes are responsible for the landforms that we see all on the Earth. So let's think about it for a second. I'm going to show you some pictures. And when I show you the pictures, I want you to just observe, because that's what scientists do. We observe. When we observe, we're looking to see anything that sticks out to us, anything to notice, whether it's the size or the shape or the color or the texture. We're just observing. So I'm going to show you a few pictures of a few things, and I explain them to you as we see it. Check them out with me. All right, scientists. So I got these pictures for you, and I really want you to take a look at them and think, how did water change or affect this landform? Let's take a look at it. I see we have water coming through here. I wonder how this hole got into the rock there. Maybe water has something to do with it. I see that it looks like a really massive piece of rock on the cliff, and there's a lot of water around it. That's our first one. Let's take a look at our second one. Here's our second one. Okay, wow. There's holes over here. There's a hole right there. There's a lot above it, and then the closer you get to the water, the less there is. There's more open space down here. Looks like it's going to tip over. I hope it doesn't. I don't think it will, though. There's a hole over here, and there's water all around it. Interesting. It's a lot of water. It looks like there may have been water that ran down here as well. I could be wrong, but it looks like that's what it looks like to me. I wonder, did water come from the top and fall down like rain? Or did the water down below have something to do with it as well? But maybe it affected the change. Let's see what else we can look for here. Let's see. Wow, okay. This is the Canyonlands National Park. It's in Utah. Look at this. It looks like, if I'm observing it correctly, it looks like water may have found its way down here after rain. It looks like this may have been a path for water to flow through. I wonder what made these holes. Probably water as well. Water's a big factor in our landforms effect and change. What else are you thinking? Are you thinking that there's some changes or some observations that you want to point out? There's a big hole at the top here. And remember, we're at the bottom looking up at this. So that would be the very top of it. And it's probably flat up top. And there's water that is a hole right here that made its way through. Interesting. So many interesting things. So let's take a moment to think, now that we have our time here today, what about what we've done so far would allow us to think, or what about how we observed so far, allow us to think about how water affects landforms? Let's take a moment to think about it, and then in a second, we're gonna draw. How has water affected these landforms? So how did water affect the land around it? Landforms are made, like mountains and volcanoes and caves, are made because water affects it. When water moves through the landform, it creates it. by moving things and moving things and pushing things out the way. I'm going to show a bit today about what that looks like and how that could be. But first, let's think about what are some other ways that you've probably seen or think that you've seen the way water might affect land. I'm going to draw one, and I'm going to show you mine, but you should be thinking about yours as well. What is a way that you've seen water affect land? Here's mine. Let's see if you can guess. Start with, just going to make it a little sun. Sometimes the sun is not as yellow as we want it to be. So I'm going to make it a little yellow, a little orange here. Here's our sun. That's in the distance. Sun. Sun is there. It's kind of hard to see, I'm sorry. But that's not the important part because we're talking about landforms. We're not talking about the sun. We're talking about landforms and how they change based on water. So this is a line, and this is all water. Water, 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 water. Sun setting into the water. Let's say this is the ocean. All the water here. And there are times, every day, thousands of times a day, water meets land and it moves it. You've probably been to a place that looks like this before. This is a beach. And all of this over here is sand. So we got sand here. Sand, sand, sand. Sand, 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 sand. And you've probably seen this before. When the water comes up to the sand doesn't just stay there. The sand moves. It either gets pushed back or it's pulled into the water when the wave hits. So the wave, let's make it look the right way. If a wave is coming in and it crashes into the sand, it either stays on the land and it gets pushed back, or it gets pulled into the water. So the water is changing the sand here, which changes the land. That's called erosion. When water is moving materials on the land and it shifts it around, it creates a new shape. Sometimes that means that the sand gets pushed back even further here and the water comes all the way up here. Sometimes the sand gets really smooth and flat. You've seen that before. That's because the water did that. And sometimes the sand that's back here doesn't even get touched at all, and it doesn't move because the water didn't affect it, because the water didn't touch it. So keep that in mind. Water affects the land. Did you think of another way? If you did, that's amazing. I'm going to show you a few examples today. We're going to do some experiments to show what that looks like, and we'll be able to observe what came from it. There are a few things that we should know. The first is that water, everywhere that water is, there's a chance for erosion. And water is a lot of places in the earth. Whether it's raining, the water that comes from the sky, whether it's water that's already in a body of water like the ocean or a sea, or a river as it passes through, all of those things are opportunities for erosion. And the water isn't just hovering over the ground and passing by. The water is touching the ground and affecting it in some way. So we're going to talk about that a little bit more. Let me show you this first example. This first example, which I'm really excited about, this first example is our way of modeling what it looked like for rain to create a cave. This underneath will simulate or be a model for the ground, the limestone that's underneath the ground. This piece at the top, the clay at the top, is going to be our dirt. And this will be our rain. When rain comes on the dirt, it seeps through and then it makes holes down below, similar to the pictures that we saw earlier. So let's grab a little bit of our water here. This will be our rain, and we'll see how it goes through the holes and then finds its way down in the bottom. We probably got to put a lot more. So let's keep going, just a lot more. As we put it through, the rain goes through the holes and finds its way down at the bottom. and it dissolves the limestone underneath. Let's keep going with the rain. As the rain tries to get through. With enough rain, it keeps going through, and it makes its way down to the bottom. There's one little hole here. We just got to make sure we have our hole so that it goes all the way through. Because the rain easily gets through the dirt, and when it gets through the dirt, it affects the thing underneath it. Similar to what we saw in the pictures up first. The rain got through, or the water got through, and as it got through, it affected the limestone underneath it. And if I were to leave this for a bit, you'll see that the limestone underneath it just passes through, and it starts to dissolve, which now gives us the holes that we want or that we see in the caves when we go in it. Have you ever been in a cave? Caves that are filled with water, at times their shape changes because when they change, because the water that got through is the water that's changing the rock around it. These rocks underneath are changing now because they have been affected by water. Not only just because of the color, but because of the shape. So if you look here, you'll see that my limestone, my sugar that was representing my limestone, is now having an effect on it as it dissolves away. Take a look at this one specifically. This one was a whole block, and now it's no longer a whole block because the water's gotten into it, and now it's changing the shape of it. That's what happens when there's a cave. The rain starts on the top, and as it rains down, it gets through the soil, and then it changes the shape of the rock underneath it. Let's take one more. As you can see, it's taking it over, and eventually it'll dissolve. You can see the hole all the way through. This was completely full, and I wasn't able to see through it at first. And now I can see all the way through it. And you can see that this piece stayed up there because it hadn't gotten wet. But the pieces that did get wet, their shape changed. And now I have a cave. The dirt and land above it, if I were to come from the side, if I came in from this part right here and walk through, that's a cave. It's dark in there, it's wet in there because the water made it through. Let's go to our next station. Our next station is teaching us about how water operates in a river. Think to yourself, how does a fast river affect land compared to a slow river? How does a fast river affect land compared to a slow river? Have you ever thought about it? Well, let me show you. This is my sedimentator. And my sedimentator has sediment at the bottom. And that's just a big word for rocks and dirt underneath it, and it's to represent the rocks and dirt that are on the earth and that they move around. We should think of this as like a river. This is a model for our river. The water's at the top, and the stuff that's at the bottom of the river is down at the bottom. When a river moves slowly by, things move, but they don't move a lot. You can see things are moving in there, but they don't move a lot. But when the water and the river is rushing, have you ever seen a rushing river? When the water is rushing, you will see that things move a lot. The bigger pieces start to move. And you should know that when water is moving slowly, some things move. Mostly the smaller, lighter pieces. When water is moving fast, you'll see that water takes the things with it, and it takes bigger pieces with it. So the faster the water moves, the bigger the pieces it can carry with it. The slower the water moves, the smaller the pieces it can take with it. It can't take the big pieces with it. So Sorry. Let's look at it one more time. Here we go. Smaller pieces. Everything just moving. Because it's moving so slowly. But when we start to have the bigger pieces, when we start to move faster, the bigger pieces are the things that start to move. And you can see, as the water moves about, it moves the bigger pieces. Take a look at that. These pieces have moved because the bigger pieces have happened. So anytime you see a really fast river, you know that it's carrying it has the ability to move some really big things. If you see a slow river, it's probably only carrying really tiny and small things. So now let's go to our next station. Our next station is a simulation of a beach. And as we talked about earlier, water moves sand in a way that allows it to either get pushed or pushed away from the water or pulled into the water. And we're going to show that a bit today. So I'll take this. I'm going to fill it up with some water here. We want to make sure we get enough water so that we can actually get some waves going. Because we're going to make some waves. And as we make the waves are going to show us what happens to the sand. Let me see here. Pour a little water. Water, water, water. Water, water, water. All right. You'll see that I have my pile of sand here and my water here. And if I take this to make the waves, you'll see that as I make the wave moves up the sand. And as the wave moves up the sand, it pulls the smallest pieces down below. Take a look at this. A little more water. Take a look at this. I hope you can see it, but the smallest pieces, as the waves move up, the smallest pieces start to make their way down because they're being brought down by the wave. The wave makes its way up, and the smallest pieces come down. And you'll see that I have more pieces down here at the end, and I didn't have any at first. But that's because the sand is moving as the wave moves. It's the smallest thing. And then imagine that happening thousands of times a day, millions of times a year, tens of millions of times in multiple years. This whole thing will look completely different. Now, to be honest, Mr. Frills doesn't have millions of years to sit here and make the waves happen, but it's just a model of what could happen. Let's take a look at it one more time. We have our sand here. We have our water here to model our beach. We're going to make our waves. And as we make the waves, you can even hear the rocks moving around at the bottom because the waves are taking the sand from the beach and bringing it back to the water. Science. Who knew? All right, I have another station that I want you to think about. This station is a little different and is going to require a bit more thinking. This station is about erosion as well. When we look at this one, I have a question. How does the amount of rain affect the landscape? How does the amount of rain affect the landscape? Let's see what we come up with. Oh, let's take it to this part here. So this part I have here, and I want us to focus on the dirt. What's happening with the dirt, and how does the water affect it? Now, this is to simulate dirt anywhere. Our water is going to simulate rain. Let's make sure we got enough. Dirt anywhere. Rain is going to be the water that comes from the top. I'm going to tilt this just a little bit so you can see what happens when it does it. Give me 1 second. Make a little piece here. Now I'm going to drop the rain down here. And I think you can already see it. The water starts to move as the rain falls down. And not only does the water move, the dirt does as well. Not only does the water move, the dirt does as well. So when it rains, rain can take the dirt and move it. What do you notice as it goes? What do you notice as the water goes? What's happening to the dirt? What's happening to the water as the rain comes down? Let's see. The water's leaking through. It's the rain is moving it. It's a lot of dirt. Lot of dirt. So as that drains, I want to come back to our cave that we started with. And we'll come back and check on the water in a second to see how it eroded because of the erosion from the water. Let's look at our cave here. Wow. Now you can see all of this now looks different, and you can see completely through now. I don't know if you've ever been in a cave, but when I've been in a cave, it looks like this. There's stuff at the top, usually it's bats, don't tell anybody. There's stuff at the top, and then down below, there's sometimes a collection of water, or just land because the water is now gone. We don't have time to sit and have all the water go away. But you can see that this part will eventually get hard at the bottom. And that's the floor of the cave, and this is the ceiling of the cave. Look at that. It's dissolved, just like that. Water is powerful, powerful, powerful. Who knew? Let's go back to check on our erosion for the dirt over here. So you'll see that we started with dirt only up here. But now the dirt has found its way down here. And it was the rainwater that allowed that to happen. As it came down on it, it moved things in this direction. And now the water is almost gone. It's still a little wet, but the water's moved on and kept going, but it's moved some things with it. Similar to what we noticed happened on the beach. Now let's look at the water where it collected, because that's also an observation that we can make. We can learn some things from that as well. If we look at where the water collected down here, you will see a few things. You'll see that the water is not as clear as when it first started. And that's how it works with rainwater as well, which also means that some of the dirt that came from the water in the first spot made its way down here, and the water is continuing to take it with it. Water is powerful, and it does so many things, like change landforms. It can change landforms of beaches, change landforms of canyons, of caves, of volcanoes, of mountains. Water can do that. Did you know that? So we've learned so much about erosion, what it is and how it works. I now want to leave us with a little bit of a book that I think is amazing that explains a lot of it. It's called What Shapes the Land by Bobbie Kalman. I want to jump forward to this page. It says, what is erosion? New land is created, but land is also worn down and carried away. The wearing away and moving of land is called erosion. Erosion changes the landscapes on Earth. Landscapes are all the parts of Earth that you can see, such as mountains, wind, rain, rivers, ocean waves, and ice all erode and wear away. The land on mountains, coasts, deserts, and other landscapes. Did you know that? But today we spend a lot of time talking about water. And I think it's important for us to learn more about how that works. This part says, it's raining, it's pouring. When raindrops fall onto land, they loosen soil and other sediments. The sediments are then splashed away and it keeps raining. This type of erosion is called splash erosion. We didn't talk about that specifically today, but it's another type. Splash erosion leaves small holes on the surface and land. During storms or heavy rainfalls, splash erosion can cause a lot of damage to the soil. The ground cannot soak up in the raindrops any of the raindrops that fall. Running off with the soil. In some places, the ground is too steep or too rocky to soak up any water. In other places, the ground may be able to soak up some of the water from the rainfall, but not all. Rainwater that ground cannot soak up is called runoff, similar to what we just saw on the pan as it was running off. Runoff trickles and flows downhill in streams, rivers, and lakes and oceans. Runoff saturates or fills the land with water. It removes the thin top layer of soil and carries it away. Take a look at that. So there you have it. In the book, what we just did. We saw the water run off and take some of the soil with it. And as it took the soil with it, it changed where the soil is. It changed the top layer of the soil, and it changed the color of the water because it was in the water with it. Erosion is amazing. It can change any landform. We have to keep our eyes open to see when it happens. Check us out next week as we spend some time talking about how to prevent erosion, because it's going to be helpful to help save our planet. All right, scientists, have a good day, and I'll talk to you later. Peace.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.